This is a good example problem where we can show you how to use the fence post method to handle conversions between quantities of different units. In this case, we have 14.7 psi, or pounds per square inch, and the question wants us to convert it to a pressure unit of Newton over meters squared, also known as a Pascal. They give us a couple conversion factors to get there, and so we'll set up our fence post. Anytime you're using any kind of conversion, you always have a quantity you're starting with. In this case, we're starting with something in pounds per square inch. In this case, we have 14.7 of them. And pound per square inch is a unit. Oftentimes you see it as PSI, but really it's pound per square inch. So it can be written this way. We have a compound unit of two different quantities, a mass or a weight in pounds, and inches, which is a length measurement, but inches squared gives you area. So it's pound per unit of areas in inches squared. And so we set up a fence post, and you have compound units in this case. We're going to put the pound in the numerator and the inches squared in the denominator. And that's where we start. So we start with 14.7, it's the quantity we have. We're going to convert pound per inches squared to a unit of newtons over meters squared. So pounds got to go to newtons and inches go to meters squared. And so I'm going to do it step by step. We're going to start with one unit at a time. So in the numerator we have pounds. We want to get rid of pounds. We have a conversion factor of 1 newton is the same as 0.225 pounds. And so what I'm effectively doing for each part of the fence post is multiplying by a ratio that is equal to 1. In this case, we want to get rid of pounds and go to newtons. Algebraically, pound and newtons are just variables. A pound cancels with a pound, just like x in the numerator would cancel with x in the denominator. And in doing so, you'd be left with newtons in the numerator, which is what I want. Now, without the actual conversion numbers in there, I wouldn't change the actual value. 14.7 newton per inches squared is not the same as pound per inches squared, so I need to write in my conversion factors. 1 newton is the same as 0.225 pounds. So now those quantities of force, 1 newton and a quarter pound, roughly, are the same quantity. So I haven't changed that amount, but by multiplying by this ratio, I've changed my units. And now we have to deal with the inches. So this is where it gets a little tricky. And the reason it gets tricky is because you have this inches squared. One way to think about inches squared is algebraically, just like x squared would be x times x. Inches squared is the same as inch times inch. And so what we have to do is cancel each inch. So we're going to set up, and in order to cancel something that's in the denominator, I need to put it in the numerator. And I want to go from inches to meters. And we have a conversion from inches to meters, so I would go from inches to meters. In 1 meter, there are 39.37 inches. And in doing that step, I've now canceled inch with one of those inches, or I can knock out the squared. So now I have units of newtons over inch times meter, which has a mixed length unit in the denominator. So I'm going to do that step one more time. Again, I can multiply by 1 as many times as I want. In this case, 1 being 39 inches over 1 meter. Those are the same lengths. And so I really haven't changed anything. So again, this inch now cancels with that inch, or if you want to look at it as the second inch down there. And now we're left with meter in the denominator, which is the same as meters squared. So now we have newtons over meters squared. And when we multiply, now all we have to focus on is the numbers. The units are matched up. And so I could take 14.7 times 39.37 times 39.37 and then divide by. The only thing in the denominator is the 0.225. If you have other things in the denominator, you got to be careful to make sure you put the denominator in parentheses, and I get 101,266. So my answer becomes 101,266 Newton per meter squared. And we've used the fence post to change our quantity. The number part has changed, obviously, because you've changed the units themselves. Now, one thing to look at as well, just as a little trick, if I'm converting from units of squared inches to squared meters, so let's say I have 2.5 meters squared, and I want to go to inches squared. I'd set up my fence post. There's no denominator in this case because the unit is just a single unit. I would get rid of meters, and I would go to inches. And I know there are 39.37 inches in 1 meter. Now, normally I would do that twice, but isn't doing the same thing twice the same as squaring it? And so one trick would be to square the whole conversion factor, which would square every part of it. All right, if you recall, if I had something like 2xy quantity squared, that 2 would go to each thing, and that would be the same as 2 squared x squared y squared. So I've just changed my conversion factor and squared the whole thing. And now in one step, I've canceled that. I'm in inches squared. 1 squared is still 1, but if you had a number down there, that would be different. And converting 2.5 times 39.37 and squaring it would get you to a big number of squared inches, 3,874. So you get 3,875 inches squared. So it's a little trick. It's really not a trick if you understand the algebra behind it. Anytime you have squared units or even cubed units, you would do it 3 times or cube it. This would come into play. So here's a little review on using a fence post method or dimensional analysis to convert units in an organized way to make sure everything matches up. Good luck.